Iedereen Nederlands sprekend? Everybody Dutch speakers, or are there also any English?
English speaker. Hello,
okay.
everybody.
Hey, hello, Thomas.
Welcome.
Okay. Then I will just do it in English then. So welcome today. I prepared a little presentation, and I hope a bit more code. What we'll do today is we will dive into one of the cases that was about TeamCity. That was a CVE this year. And what we will do is see how we can reverse engineer such a vulnerability, because in this case, there was no proof of concept. And it was a little bit difficult to have a good and correct fingerprint ready. And because I like to dive into code, so that was also nice. Please feel free to interrupt me, ask anything if anything is not clear, or just feel free to shout or put up your hand. But sometimes shouting is better because I will not always be able to see everything. So a little bit about myself. I myself am a software researcher, so that means that my day-to-day job is researching mainly web applications, but also web services, APIs, to distinct that more from like general programs. Most of the time we do assessments on applications, and I do that by reviewing code, but also conducting pen tests. And I have a lot of experience, 18 plus years already as a developer. And now the last couple of years I've been a security researcher. So what was the case? There was a CVE on TeamCity. It was not the first on TeamCity, and it certainly was not the last on TeamCity. To give a little bit of context, TeamCity is a product developed by JetBrains. It's a so-called build server. So that means that the software development teams, if they make their software, they want to build and compile it. And there are certain products that can do that kind of stuff. TeamCity is one of them. And what is nice about, or nice for an attacker, nice about TeamCity is that most of the times it's on the internet, needs to be easily accessible. And because it's a build server, there are a lot of possibilities to execute code. So by its nature, it needs to run and build code. So if you can get access to such a server, most of the time you can also take over that server and then look into the rest of the network. So a little bit about the context of the. You go to the website of JetBrains. This CVE said that there was a vulnerability that may enable an unauthenticated. They say may, but it enables an authenticated attacker with access to the team server to bypass any authentication check. And because you can bypass any authentication check, then one of the things that you could do is add a administrative token. And then with that token, you can do any of the functionality that was on that team server. And if you look into the classification, we have the so-called CVEs. There's another one who wants to admit. Kinds of problems that can arise in applications. And the one that was in the documentation for this CVE was that it was a so-called authentication bypass using an alternative path or channel. And most of the time that means that there is something you can send in to bypass all the application. And what is to vulnerability? We can take a look at a previous one, 2-3 months previous from this vulnerability. Also in TeamCity, that was CVE-2023. CVE-2024-23917, and that had also the same classification. So that had also the authentication bypass, and that is one thing to keep in mind if in a couple of minutes we are going to search for the vulnerability. And this one was problematic because intelligence was pointing that also the Russian Foreign Intelligence Service was actively exploiting this CVE, so the 2023 one, to actively get access positions on team servers. So this was a real thing that was used by the Russian Foreign Intelligence Service. And this is something to keep in mind if we go into our CVE, because this one there is a very nice technical block on the Rapid7 side. And one of the things that they show there is that in the code of this product, there is a so-called pre-handle method. And let me explain a little bit about web applications for those who don't work on a day-to-day basis with web applications. Most of the time, if you have a big web application, and it doesn't matter in which language, I've seen it in Java, I've seen it in .NET, in any languages, you have all kinds of routes that could lead to an API or that could lead to a website. Most of the time they have authorization, but sometimes the developers have the need to bypass certain stuff. For instance, they want to bypass authentication. Most of the time that's not a very good thing to do, because most of the time that are the points where we can actually find vulnerabilities. But in the case of JetBrains, there was the so-called pre-handle method, and that is a method that is called on every request. So every request that goes to that web server goes to this pre-handle method. And I will tell you a little bit more later when we dive into the code. But what this one was doing is checking if certain conditions are met, and then when they are met, authentication is skipped. But it should not be skipped for every method. But as we will see in a moment, we can do that actually. But this is very good to keep in mind, because the vulnerability that we are going to show was exactly in the same kind of code. So 3 months previous from the vulnerability, there was some exploit, or there was a vulnerability in a part of the code, and like 3 months later, I think almost the same part of code was affected, different kind of functionality, but still it was affected. So that's something to keep in mind. What's also good to note is that for the particular CVE that we are going to discuss, as of yet, I did not see any proof of concepts, because I think the researcher that found this one first did not disclose anything. Rapid7 has quite an aggressive policy on disclosing things, so that's why they wrote a technical blog. And so I think 4 weeks ago there were another 2 CVEs on TeamCity found by Rapid7, and those are disclosed. And the nice thing is that they are still around the same kind of code path that this vulnerability was in. So there was a lot of problems in this in this code path, so to say. If you have any questions, please feel free to ask. So now about the fingerprinting. So we, as the DIVD, we wanted to had to search for servers that are active on the internet and that had this vulnerability. So if you go to the or you came to the website of JetBrains when a new version was published, so there was a new version published, and the text that is now on the presentation was what is still on the website, that there is a new version, but and there's where the crux lies, why we needed a different method of fingerprinting. There's also there was a quick patch, a hot patch, a plugin, and if for some reason you were not able to update to the newest version, so the 2023-11.3, then you could activate that plugin. But that also means that there was a very simple way to identify team servers, and that is if you just request the index page, then somewhere in the HTML there was a version number. But because of this patch, even if it was an old version, you are not really certain if somebody just installed the plugin or not. So we need another way to be like 100% accurate on scanning this server and to know for sure, okay, even if I find an old version, it still has this vulnerability. And that's why we took it on us to dive into the code and see if we could find a better fingerprinting method. And the nice thing, and that's one of the nice things about TeamCity, is that the server code itself, but also the plugins are just readily available on the website. Even the older versions, you can still find them online. You need to decompile them because they are Java. And I also go a little bit into that's the stuff of decompiling. But still, at least we have access to the code to do some researching on it. So what was the plan? The plan was, first get the patch to see if in the patch itself there was some information that leads to, okay, what kind of vulnerability do we have here? Sometimes in the patch itself, they directly patch the vulnerability. Sometimes they don't. In this case, they didn't. They did quite a bold move in that they just blocked everything that should not be allowed anonymous. So this was really like we are in panic mode and just try to block everything. So we'll see in a minute that we actually cannot learn anything from the patch itself. And if that fails, and we know by now because I told you so, this will fail. Maybe we can just look in the code itself and then try to find any root cause there and see if we can rediscover the vulnerability and then make a better fingerprint from it. So now we go more like into the technical stuff. So from here on, this will be the last slide. After that, I will jump into my other machine, and we are going to see some Java code. So what were the steps? So first, let's see if we can decompile the patch, because the patch itself is just a jar file. For everybody who worked with Java, that is a archive file in which you can find the compiled bytecode. So Java is a language that compiles to a new kind of code. It's called bytecode, and with some tools, with decompilers, you can try to recompile, reconstruct the actual code. But we find out, well, at least I found out, that it was obfuscated. I find it a bit curious because they obfuscate all their hotfixes, but the code itself from TeamCity itself, it's totally not obfuscated. It's also very easy to de-obfuscate, so I don't really see the point of obfuscating your code, but maybe they try to add that other adversaries or people or attackers, maybe they're a little bit slower, but I don't think they really slow them down. Okay. It's just a thing. So reverse engineer the patch, and with that patch we didn't have any luck. Then see if we can reverse engineer the code, and then see if that first hunch of, okay, we see the same CWE. My first hunch was just to look at that same spot of code, and lucky us, it was actually around the same spot of code. And then see if we can find a path and see if we can then build a nuclei template from it. And so that are the steps that we are going to conduct. Any questions from this point? Because now I will go and share my other screen. Present something else. and then a window, and then where do I have it? Here. Okay. So I hope you can all see my screen. I will build it up a little bit like the plan that we did. So what I first did is I downloaded the patch files. So there is there are actually two kind of jars. One is to activate the plugin, and one is the actual plugin itself. And the actual plugin is let me see, it is in that security patch plugin. And if you go to the first thing I did, it was actually in the patch common, the code. So the first thing I did was try to decompile this. So I use a program called GD, gcompile QE. You can use also IntelliJ or anything that can decompile. And the first thing that you see when you try to decompile this one is you only see bytecode. And this is that special code that Java produces. It's called bytecode. You see there are no strings in it, so we don't see any specific information. And for anybody who worked with obfuscated code, it's obvious this code is obfuscated. So they run a program in Obfuscator, and that tries to hide strings. It tries to hide the general code, that it's not this easy to reverse engineer the code. Okay, but we have a trick, and there is a nice program called DIVD.jar, and the first thing that we're going to do is let me see, is try to run that program, the deobfuscator, and it has two modes. One is a detect mode, and then it tries to detect what kind of obfuscation is used on this jar file. And if we run this, we get quite a quick and nice hint, and it says that it's using, and in the Java world, it's one that's common used. It's Selix classmaster. It's a obfuscator. And on one of the last lines, we see that it tried to do something with string encryption. So this deobfuscator, it detects this obfuscation method, and then now I did it in the detect mode, and then you can run it in like the deobfuscate mode, and then what's going to do, it will give me a Java file. So again, it's a decompilation, but now it's a little bit more readable. So some things are still missing, and that's because that obfuscator removes things like class names and method names. What you could try to do now, if this was a very big file, is you can try to rename stuff and see if you can make more of it. But for me, I worked a little bit with, I work a lot with Java and a lot with .NET. So I can see the general construct of this patch. And so you can see now we can see strings. So that the obfuscator removed the encryption of the strings, and we can see that this is a patch for that CVE. And what it tries to do, you see all kinds of strings here. For instance, up agent and update, and then you can see that there are a bunch of controllers, and controllers are in the Java world and also .NET world are a way, if you have a specific route, for instance, you want to log in, or you want to, for instance, administer something, then you go to a specific controller, and that's what we see here. We see all those controllers. So from this, you can see, okay, it builds a list of those controllers. It also tries to check if the path starts with certain names, so app agent and update, and then it directly returns. So what this does is that if the path, the route that's coming in is app agents, then it skips any further handling. So this is one of those things that in the pre-handle is also skipped. So this is something that should be actually be accessible anonymous. So what they do here is say, okay, if this path comes in, don't do anything. Anybody is allowed to do that. And that's also on the update. Why? Because here artifacts of TeamCity are stored, and anybody should be able to go to those routes. And then it builds a big list of controllers. And what you see here is that it tries to check this code and this code. It tries to iterate, so goes through all those controllers and tries to see, are you trying to access any one of those controllers? And if so, you are also they also return a true, so it's okay. And you can see it are things like forgot password, reset. Those are also things that should be accessible anonymous. And then, and this is the root part, so they say anything but this, access denied. So what I try to do here is just, okay, anything other, what you try to do, no matter what, you will be blocked, and you will be, you get unauthorized if you are not authorized already. And this is what I said previously. So this is quite a rude way to block. So they block off anything that's not in this list. This was really a hotfix. And we don't really learn anything about the actual path. So we see that there is a problem with authentication. They obviously try to fix something with authentication, but not what they really, what are they really doing? So now we need to go to our original plan and see if we can decompile the code of TeamCity. And hopefully it's not obfuscated like this one. And it's not. So one of the things for the people who are a little bit new to web applications, Java web applications, and you see it here in the mouse over, here's it again. Most of the times the classes that make up the application are stored in the web info folder. So what I did was go to that web info folder and see what are all the YAR files that make up that application. And from that you will see that there are a lot of third-party libraries, but you also see that there are some YAR files that are made by JetBrains. And one that that stood out was this web YAR, because if you think a little bit about web applications, and maybe most of the code will be there, and in this case it was. And the first thing I did was try to look at that code from those previous CVEs, because I already thought, okay, it was the same kind of class. Maybe there's something more wrong. Maybe they made an error in fixing, or they did not patch anything else. So the first thing I did was look up that pre-handle method. I think you can all read it. So this pre-handle method, every time something is called on TeamCity, this method is actually called. So what you can see are a couple of things. And I will first show you the old, at least where the old arrow was. So you see that they check, is a pre-request handling allowed? And we will come back to this method because the actual problem is in this method. But here on the bottom, let me see if the pre-handling is allowed. It is on the bottom here. You can see that they check also a list. So they make a list of paths that you are always allowed. And we will see in a moment, for instance, I think also the update method is there. And if we go to that method, where is it? So it's here. Not to update the app agents. So you see here that the app agents we saw previously that should be allowed anonymous is also here. It's app agents and then ***. So anything that's added after this path and it starts with app agents should be allowed. And there's also another line, and this one is very interesting. This get XML RPC controller, because the previous CVE was in this line, and I can go to the technical block here. Here you see a diff of the previous version and the version that we are currently handling. On the left, you see what was wrong. So what they did, they said that any path and then the path suffix, and in this case the path suffix was RPC2. So if you have anything and then just RPC2, then you could just go to all the paths. And the error with that was that you can make up a path that ends with RPC, but that does nothing with that RPC. But still it ends with RPC. So the application thinks, okay, you end with RPC and the rest on front of it doesn't matter. You are allowed. And they changed it. So you can see that now they removed that star. So you cannot add anything in front. You just need that path suffix, that RPC2. And that was one of the fixes that they did for that previous CV. But now for the one that we are handling, we're still in this request pre-handling allowed method. You can also see that the actual code of TeamCity is very big. And this is not the only YAR that any files are in. There are more files that custom code is in. And we will come to one in the next bit. So what we see here, the request pre-handling allowed. And we see here something on this line. And it says that if this is a pre-compilation request, then the pre-handling is not allowed. And in this code, it means if pre-handling is not allowed, then you will skip any pre-handling. So any authentication check, anything whatsoever. So this immediately triggered my interest. So let's see what's in this code. If I can somehow make this code return true, and still have a path to a nice and interesting thing on TeamCity, and then we may have found our vulnerability. After some searching, I found that method. It was in a web util class, and this was one that was in another archive file, so in another YAR file. We can still decompile it. We can see all the code. Not everything is nice, but most of the stuff is readable. And then we have this interesting line. And this is where the magic happens. So it says that we get the request URI. And in a moment, I will show you the documentation about this request URI, because this is actually where the actual vulnerability is happening. If it ends with .gsp and it contains a parameter JSP precompile, then it will return true. And then we already saw in the code, if it returns true, then pre-handling is skipped, and we are in. So the second part is actually pretty easy. If you do a request to a web server, you can always send it any parameter. You can just add a question mark and then the parameter. And if there are already parameters, you can just add an ampersand. So this one is easy. To any part, we can always add JSP precompile. Doesn't matter, we can just add it. So we're safe on this one. Now we need somehow to end our request with .jsp, but we don't want to go to a JSP page, because if we do this naively, we just say we want to go to there are REST APIs /app/rest and then admin. We can't just do admin.jsp, because then this web application would try to look for a admin JSP page. It's not there, and it will just return a 404 and nothing interesting. So the interesting part is, okay, can we somehow manipulate the URI in that it still ends with JSP, but that we still end up on any part of this application. And I think this is where developers sometimes, and it's also difficult. I mean, the URI specification is difficult. You can put you can put all kinds of weird stuff in URIs. You can put usernames, passwords. One of the things that you can do in Java is that at the end of a path, you can end a punt comma, so semicolon, semicolon, so a dot and a comma. And then after that, a Java servlet application would try to interpret that as a JSession ID. So it will get that URI, and then you can put a JSession ID there. But we can also try to put some nice stuff there. We can try to put a JSP at the end of the URI, and then it will not be processed because the application thinks, okay, it's a JSession ID. Everything before that will just be interpreted as the path, and then a JSession ID. So let's go to that get request URI method. Here is the documentation. And it says that it returns the part of the request URI, the protocol, up until the query string. So the query string is where all those parameters are set. And anything before that will be returned. And in a moment, we will see what that means. So, okay, I think we found our path. If some way we construct a URI, in that it will end with this JSP. And now let's see if we can do that. What I did, you have all kinds of endpoints, and there's also something to keep in mind when you're going to scan stuff. We try to hit endpoints that don't manipulate the application or retrieve sensitive information, but in this case, still we need an endpoint that returns a authorization error. So it should not be an arbitrary endpoint. We should actually get a authentication error. In this case, I found a health endpoint. Most of the time, health endpoints are unauthenticated, but in the case of TeamCity, they are not. They just return the health, but still they are authenticated. So if we are going to request that URI, we can see that we got a 302. This is a redirect. And we are redirected back, and you can see it here, to the login page. So this means, okay, you've hit an endpoint, you need to be authenticated, but you are not. So return to login. And now we are going to try to reconstruct that that actual path. And this is where the actual vulnerability arises. We need to make it end, so the URI, we need to make it end on JSP. That's what we do here. If we do it like this, I will send this one. Now you can see that it sends a 404 because it tries to get the help.jsp page. It's not there. You can see we can just add that precompile parameter. It will do nothing, but as we saw in the code, we will need that one to make that if statement true. Okay, but we also learned that we can send in the URI JSession IDs, and then the application will see that as a JSession ID. It will remove it, and it will still call the rest of the application. But our recurse URI still ends on JSP. So now, what will happen? Okay, we get a 200. And you also get some health status count. And this means that at this point, any URI we have before that JSP will be accessible. So it can be admin endpoints. And in the case of that CVE, I think they described it already here. And that's something that I did not want to do, because now we are actually not only trying to find a vulnerability, but you are actually exploiting it. But this information is already out in the open. But what they did is there is a API REST user, and there you can register a new application, or you can register a new user. And what they did at Rapid7, they tried to issue a new token with the admin credential. So you get back a token, a bearer token, that you can then use to call any API. So in our application, if we did this with the tokens, a post, but then we append our vulnerability with the .jsp, then we would also be able to call this method. And you see here that they use that RPC2 trick to bypass any authentication. And yeah, in my case, we used the .jsp trick to bypass any authentication. Okay, so at this point, we can establish 100% for 100% that it is this version, that at least it is the version with this vulnerability, because at this point it was not disclosed. And also what I did, and I will not show it here, but what I did, I applied the patch and the plugin to see if it is fixed and if I actually have the, because first I thought maybe this is an actual 0-day, could be that it's a different part altogether, but I applied the patch and also the plugin, and then the vulnerability was gone. So I was quite sure that this was the vulnerable part that was fixed in this version for this CVE. And then I also know for sure, okay, if we call this part, it's it's not a dangerous part, you just get a 200. So we can also use that for scanning. Then this, I did not do it myself, but somebody else took the part that I found and then put it in a nice nuclear template. It was actually Alwyn. And what you see here is what it tries to do is first it gets the login page, because there it can get that version number. So we establish the version number. And then the second thing is we try to call that health endpoint. And what we did in this case was instead of just JSP, we added a DIVD identifier so that anybody in the logs, they know that it was the DIVD that triggered this scan, or somebody that knows this kind of string. But okay, I'm quite sure that we were the ones that are actually using this one, and also because it was a harmless endpoint. So no harm was done in us. But now, if we combine those results, so we combine the version and we combine that endpoint, now we know for sure it is this vulnerability, it is this CVE, and we can start scanning and then also notifying people who run, at least at that point, run that vulnerable version. The CVE, the two CVEs that came after this one, they actually, I think after 1 day, Rapid7 already published a large article about that, about the vulnerability, and they had a little bit of, at least what I read on the internet, a little bit of discussion with JetBrains about if they could publish it or not. Okay, but that's up to them. So yeah, that was it for me on how I rediscovered this vulnerability. For the people who want to do this, it actually takes a lot of time to actually find the piece of code that does this vulnerability. So if you look at this URL, you think, this is rather easy. But to try to spot this between all this kind of code. So one of the things that you could improve making this faster is have a better setup. So if you already have all those YAR files decompiled, and if you have it, for instance, in a better IDE like JetBrains, and you have the versions, and you can, for instance, run beyond compare or anything, I think you will be faster in trying to identify the vulnerabilities. But that's something that that can be improved upon. But this is how you can try and see if you can rediscover a vulnerability.
Thank you, Gerben. Great explanation. Yes. Thank you for the details. Anyone has a question?
So Owen says, thanks for the nuclear template. Yeah, you made a nice nuclear template, so thank you for that. Any questions on maybe on? You can also on reverse engineering or on this CVE or.
Hi, Gerben. Thomas. So I'm trying to get into the field, so I'm not even there. Web applications would be an area where I want to focus. What, like reverse engineering web applications to find vulnerabilities, which is what you're doing. Mostly, what languages would you recommend focusing on?
So if you really want to dive into of the web applications, and on the other hand, you have like more like the edge devices like routers or other special things for web applications. Yeah, a lot of enterprises still use so this language that I showed you, Java. So Java is a good language. Currently, a lot of applications are made in Node.js also. .NET. So I work a lot with .NET, and that's C#. But what you will find out is, and I think it's also good to learn to develop this application yourself. So not even find vulnerabilities. Just start developing those applications, and you will see that most of the time they have the same pattern. So that's why I know, okay, this pre-handle in .NET, they have things like middleware, and that's also something you have in Node. And if you know that kind of patterns, then it will be easier to dive into this stuff. So I think it's important is first learn to develop those applications yourself, and then learn how to find vulnerabilities in them.
Thanks. And again, very interesting.
Okay.
Well, if there are no more questions, then again, I want to thank Gerben for your presentation. And we love to see you all next month again when we have a new DIVD-Community presentation by one of the DIVD staff. If you're from one of the community members here and you would like to share your own project or your own skills within this community, then please reach out to us, and then we'll plan it in and we'll make it happen. For now, I want to thank you all for joining us this evening, and I hope to see you soon again.